The greenhouse effect. The greenhouse effect is a natural process whereby gases and clouds absorb infrared radiation emitted by the Earth's surface and radiate it, heating the atmosphere and the Earth's surface. The Earth's average global temperature is 15 degrees Celsius. Without the natural greenhouse effect and the rest of the climate system, it would be about negative 18 degrees Celsius, which is too cold for life. And you might think, okay, well, we've had days of negative 18. Well, the difference between us now and an ice age is only 4 degrees. So if this were to drop down to 11 degrees Celsius, that would be considered an ice age. So if the average temperature actually dropped to negative 18, it would be detrimental to all life on Earth. So let's look at the greenhouse effects. We got this little cycle that happens. And first, well, we have energy from the sun passes through the atmosphere to reach the Earth. The Earth's surface warms up and radiates out lower energy infrared radiation. So sun beats down on us, the Earth warms up, okay, and gives off infrared radiation. Next, gases in the atmosphere absorb this infrared radiation and radiates the energy back in all directions. Some of this radiation goes back to Earth's surface and warms it up even more. So it's a cycle. So it goes up, heats up, bounces back down, heats up more, bounces back up. As a result, much of the radiation from the sun is trapped in a cycle between the Earth's surface and the atmosphere. So it's called the greenhouse effect because there's gases in the upper atmosphere that traps all the air in. So greenhouse gases absorb lower energy infrared radiation emitted by the Earth's surface. Most of the air in the atmosphere is nitrogen and oxygen gases. Greenhouse gases exist in very low concentrations in the atmosphere. So people think there's a huge amount up there, and actually there's very, very little, but they're very effective. So the main greenhouse gases are, number one, water vapor. So water vapor actually acts as a greenhouse gas, and it makes up about 2/3 of the greenhouse gases. The next one is carbon dioxide. So carbon dioxide causes up to 1/4 of the natural greenhouse effect on Earth, and it comes from both natural and human sources. So natural sources is stuff like volcanic eruptions, burning organic matter, cellular respiration, which is when we breathe out more carbon dioxide than we take in. So living things in oceans are also important because when they're alive, they actually absorb the carbon dioxide and they hold it. Once living things in the ocean die, what will happen is they release that carbon dioxide. So you don't want all of a sudden to have a mass extinction level event in the oceans because it will release significant amounts of carbon dioxide. Next is methane gas. So methane gas is CH4. That's a formula you should start getting used to seeing. So when you see CH4, you're like, oh, that's methane gas. So there's much, much less methane gas than carbon dioxide, but it is 23 times more powerful of a greenhouse gas than a carbon dioxide molecule. So you don't need very much of this, but it's very, very potent and powerful. Natural sources of methane gas include plant decomposition in swamps and animal digestion. The next one is tropospheric ozone. So ozone is O3. When you see O3, it's ozone. O2 is oxygen gas that we breathe in, but O3. So this is in the upper atmosphere. It does exist down here in the troposphere, but it is a poisonous gas to us. So we don't want it in the troposphere. We want it in actually the stratosphere where it blocks out UV radiation. So ozone does protect us from the sun. And it also is a greenhouse gas as well. So it kind of has a double effect. So when it's in the stratosphere, in the upper atmosphere, that's where we want it. It protects us from the UV radiation. However, when it's closer to the Earth's surface in the troposphere, and that's made from human sources, okay, it acts like a greenhouse gas. It's also a poisonous gas to us as well. The last one is nitrous oxide, so N2O. And again, significantly less of this than carbon dioxide, and it's almost 300 times more powerful of a greenhouse gas than the carbon dioxide molecule. So everyone's always worried about carbon dioxide, but some gases are much worse than carbon dioxide, like ozone and methane.